Welcome back to Mr. DuPage's classroom. This lesson is from my Algebra 1 class. It is 10.6, Day 2 notes, talking about the quadratic formula and the discriminant. The warm-up here, you should know what the quadratic formula is. It is the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Solve each quadratic equation using the quadratic formula. The first step here is I have to add 3 to both sides. We have to have our equation set equal to 0 before we can solve. And we want our order to be the ax squared term, then the bx term, and then the c. Okay, so my a then is 2, my b is 10, and my c is 3. I go ahead and plug that in the quadratic formula. X equals the opposite of b is negative 10 plus or minus the square root of 10 squared minus 4 times 2 times 3. All of that then is over 2 times 2. Okay? At this point, what I can do is simplify everything underneath the square root. So 10 squared is 100. Minus 4 times 2 is 8, negative 8. And then negative 8 times 3 would be negative 24. That's over 4 because 2 times 2 is 4. Okay? Now what I need to do is to go ahead and take 100 minus 24. So x equals the opposite of 10 or negative 10 plus or minus the square root of 76. All of that is over 4. Now, when I take the square root of 76, I'm going to end up with a decimal, and that is okay when I'm doing a quadratic formula. That is actually okay when I'm doing the quadratic formula. Okay? So I have x equals negative 10 plus or minus the square root of 76 is 8.71779. So I'm going to round that to 8.72. All that's over 4. Now, if you remember from our first discussion, this is actually 2 separate equations. So I want to split it at this point. One where I'm going to add the 8.27 or 72, and one where I will subtract the 8.72. Now I can go ahead and use my calculator. Negative 10 plus 8.72. Then divide that by 4. So x equals negative 0.32. Negative 10 minus the 8.72 and divide by, and then divide that by 4. I end up with negative 4.68. Now on b, I have to subtract 6x from both sides again so that my equation is equal to 0. So it would be x squared minus the 6x minus 4 equals 0. A then is 1, b is negative 6, and c is negative 4. So x equals the opposite of b would be positive 6 plus or minus the square root of negative 6. Sorry, that's weird looking. Negative 6 squared minus 4 times 1 times negative 4 all over 2 times 1. We can simplify what's underneath the square root. So negative 6 squared is 36. Negative 4 times 1 times negative 4 would be positive 16. So I have 36 plus 16 over 2. 6 plus or minus the square root. 36 plus 16 is 52. All that's over 2. Now I can take the square root of 52, which would be 7.21. And now I need to split into 2 separate equations. 6 plus 7.21 divided by 2 is 6.61. minus 7.21 divided by 2 is negative 0.605. If you have a decimal that ends after 3 decimal places like those two do, go ahead and write out the whole decimal. Because that's an exact answer where if you round it, it's not exact, okay? Now on to our story problem, just like what we did in day 1. Cannonball is launched at 1,500 feet per second. That's going to be my initial velocity, or my VO. So I can have h equals negative 16t squared plus all of that beginning part that I've written down so far is always going to be that way. H equals negative 16t squared is always going to be there. Instead of VO, then I'm going to write 1,500t. And it says an initial height of 10 feet. So instead of HO, I'm going to do plus 10. Set up the formula first. That's what we just did. Approximately how long after launch will the cannonball reach a height of 10,000 feet? Well, 10,000 is going to go in for this H. So I have 10,000 in for H. Before I can use the quadratic formula, though, I have to get this set equal to 0. So I'm going to subtract that 10,000 from both sides. Since 10,000 does not have a variable, it will be subtracted from our 10. So 0 equals negative 16t squared plus 1,500t minus, this would be 9,990, okay? So my A value at this point is negative 16, my B value is 1,500, and my C value is negative 9,990. We are looking for our time, so our variable is going to be t. It's going to be the opposite of my B value, so it would be negative 1,500 plus or minus the square root of 1,500 squared minus 4 times my A value, which is negative 16, times my C value, which is negative 9,990. All right. All of that over 2 times negative 16. So t equals negative 1,500 plus or minus the square root. Now, everything underneath the square root, if you type it in to your calculator using the parentheses, you actually can get all of that information at one time, and you can simplify the whole square root all at once. So it'd be 1610640. So that's actually 1,610,640 all over negative 32. I can take the square root of the 1,610,640. So t equals negative 1,500 plus or minus. So the square root of 1,610,640 is 1269.11. All that's over negative 32. Now I can split those two. Plus my 1269.11. And I'm going to have a minus that as well. So I have negative 1,500 plus 1269.11 divided by negative 32 ends up being 7.22 seconds. Now, if I'm going to run out of space here, so I'm going to have to erase this after I get done with this. So this went here, my negative is going to come down here, okay? If I take negative 1,500 minus the 1269.11 over negative 32, I end up with 86.53 seconds. Well, how does that work? What we're looking for is when the height of our cannonball will reach 10,000 feet. So you got to think about this. It's going to start at 10 feet. It's going to go up and then come back down. Well, 10,000 feet could be somewhere up in here. So it actually reaches 10,000 feet 2 different times, and that's why I actually have two answers to this problem, because the first time it reached 10,000 feet was the 7.22 seconds. The second time it reached 10,000 feet was 86.53 seconds, okay? Now it wants to know it's going to reach 20,000 feet. So again, I would put 20,000 in for, I would put 20,000 in for my H instead of 10,000. I'll write out everything again. I would have to subtract the 20,000 from both sides. So 0 equals negative 16t squared plus 1,500 minus 10 minus 20,000 is 19,990. Now that I know that my C value is negative 19,990, I can go ahead and put it in the quadratic formula. The only thing that's going to change from the problem above is my C value. So everything else is going to be exactly the same. Meaning that my denominator of my fraction is going to stay negative 32. I can go ahead and calculate what's underneath my square root. So it would be 1,500 squared minus 4 times negative 16. I forgot to put the negative 16 in there. Sorry. Board's going slow now. Times negative 16 times negative 19,990. So we'll end up with the square root of 9,70640 all over negative 32. The square root of that number then is 985.21 all over negative 32. I'm going to need to split this now. So I'm going to move over to the right here. So t equals negative 1,500 plus 985.21 over negative 32. And t equals negative 1,500 minus 985.21 over negative 32. I can go ahead and calculate each one of those. So t would happen at 16.09 seconds. And it would happen at 1,500 minus 985.21 divided by negative 32. It would happen at 77.66 seconds. So as you can see, from day 1 to day 2, our story problems are pretty much the same. I'm just going to be changing some numbers. If it asks for a specific height other than the ground, then you need to put that number in for h, subtract it over, and then we'll get to work, okay? Now it says consider the graphs of the functions below and the discriminant of each related equation. The discriminant is the part of the quadratic formula that's underneath the square root, so it's b squared minus 4ac. As you can see down here, it's actually calculated that out for you. And the question becomes, what does the discriminant actually tell me? Well, the discriminant will tell me how many solutions I have. So the solutions on these graphs, there's those solutions. Here's a solution. There aren't any solutions on the third graph. So this first graph has 2 solutions. What do I notice about the discriminant? It is positive. The second graph has 1 solution. I notice that the discriminant is 0. The third graph has no solutions, and I notice the discriminant is negative. So if you remember from our last unit, if I take the square root of a positive number, I'm going to get 2 solutions. I'm taking the square root of my discriminant. So that would tell me that I have two solutions. If I take the square root of a 0, I have one solution. If I take the square root of a negative, I would have no solutions, okay? So that is what our discriminant will actually tell us. So that means that for a quadratic equation, if the discriminant is positive, there are two solutions. If it's negative, there's 0 solutions. And if it's 0, then there's one solution. So what it wants us to do now is to find the number of solutions using the discriminant. So I'm just going to use b squared minus 4ac. So b is negative 5 in this case, so I take negative 5 squared minus 4 times a, which is 3, times negative 1, or times my c, which is negative 1. This tells me that I have 25. Negative 4 times 3 is negative 12, times negative 1 is positive 12. So that means my discriminant would have been 37, which is 2 solutions. On to 2. My a is 1, my b is negative 2, my c is 3. So this would be negative 2 squared minus 4 times 1 times 3. This is 4, because negative 2 squared would be 4. Negative 4 times 1 is negative 4, times 3 is negative 12. 4 minus 12 would be negative 8, so I have no solutions. And 3, my b value is negative 4, so negative 4 squared minus 4 times 3 times negative 7. This would be 16. Negative 4 times 3 is negative 12. Negative 12 times negative 7 gets me 84. So this is 16 plus 84, which is 100. So I have two solutions. And then the last one, I have to have it set equal to 0 first. So I need to subtract the 2x. So I have 5x squared minus 2x plus 8 equals 0. My b value then is negative 2. I need to square that. Minus 4 times my a, which is 5, times my c, which is 8. This gets me 4. And negative 4 times 5 times 8 is negative 160. So 4 minus 160 would be negative 320, meaning I have no solutions. So if that discriminant would have turned into 0, so instead of having 100 on problem 3, I would have gotten 0, then we would just have the one solution. Now, the other thing I can use the discriminant for, I can use the discriminant to kind of be a little bit of a shortcut for myself, so I don't have to write out the quadratic formula over and over and over. Okay, so a construction worker on the ground tosses an apple to a fellow worker who's 20 feet above the ground. The starting height of the apple is 5 feet. Its initial upward velocity is 30 feet per second. Will the apple reach the second worker? I still would like to fill out, just like we did before, initial velocity is 30, so 30 is going to go in as my b value. And the starting height is 5, so that's going to go in as my c value. We're looking to see if it's going to reach 20 feet above the ground, so that goes in for my h. Before I can use the quadratic formula, I have to set it equal to 0, so I have to subtract the 20. Now, at this point, I could write out the entire quadratic formula, but that takes a lot of writing. So what I also could do is just figure out my discriminant. And if you're going to use this trick, I need you to write the word disc so I know you're using the discriminant. The discriminant is b squared, so 30 squared, minus 4 times a, which is negative 16, times c, which is negative 15. Okay, so when I do 30 squared, I get 900. Negative 4 times negative 16 times negative 15 is negative 960. So 900 minus 960 ends up being negative 60. Because the discriminant is negative, that means if I were to do the full quadratic formula, I would find out that my square root is negative, which means that I have no solution. So it asks the question, will the apple reach the second worker? The answer to that question would be no, because my discriminant is negative. It never did reach that. I don't have a solution to that problem. Then it says, what if the apple is tossed with an initial upward velocity of 32 feet per second? So the only thing that's going to change, I'm going to use this equation, and the only thing that's going to change is this 30. Instead of being 30, I'm going to use 32. Because everything else is the same about the story. I can use the discriminant to check and see if it will reach the second worker. So 32 squared, b squared, minus 4 times a, which is negative 16, times c, which is negative 15. So then I have 32 squared, which is 1024. I know negative 4 times negative 16 times negative 15 is 960. So 1024 minus 960 ends up being 64. So yes, I know that it will actually reach the second worker. Well, how can I use this 64 to make my life easier? I can start out writing the quadratic formula like normal, opposite of b, plus or minus the square root. Well, I know underneath the square root is my discriminant, so I can just say that my square root, or that my discriminant underneath the square root is 64. And I can take 2 times negative 16, 2 times a. So that is the quadratic formula. I did all of this work over here, which allowed me just to put that answer right there. Now I have t equals negative 32 plus or minus 8 over negative 32. I would need to split it, so t equals negative 32 plus 8 over negative 32, and t equals negative 32 minus 8 over negative 32. So negative 32 plus 8 is negative 24. T equals negative 24 over negative 32. Negative 24 divided by negative 32 would be 0.75 seconds. And then negative 32 minus 8 is negative 40 divided by negative 32. So this would be at 1.25 seconds. So it actually would reach the height of that second worker at 2 times, and those are the 2 times. So that is your discussion on review of the quadratic formula itself and the discussion on the discriminant. Make sure if you have any questions, you let me know. Otherwise, thank you very much for watching the video, and have a great day.